are all doing very well. Keep an eye. Let the string become taut. Don't hold the string. So can you just hold that? Just yes, the young girl in the yeah. That distance from over there to there is going to represent the distance from the Sun to the orbit of Neptune, which is the size of the solar system. If you remember, we kicked Pluto out. I'm sorry about that. It had to be done. Now, so I don't get this wrong. You'll notice it's just a piece of string. I haven't attached any planets to it. There's a very good reason for that. The Sun on that end is the size of a pea. Actually smaller than a pea. About half the size of a pea. So if you look at the board behind me and think how small all the other planets are, there's no point attaching them to the string. You can barely see the string. So, let's get... where are we? Yes, good. Mercury on this scale is about 20 centimeters from that side, so a bit less than a foot. Yes? And you could fit 100 of them across the thickness of that string. Venus is another 20 centimeters on. You could fit 40 of them across the string. Earth is about 60 centimeters, or about halfway across the aisle there, I think, maybe the whole way. And Mars is about a meter from that side, and you could fit 73 of them across the length of the string. Now, there are 8 planets in the solar system, and we've only got a meter from that side, and we've already got 4. So you can see that the inner bit of the solar system is quite packed in relative terms, obviously. It's just all empty space. Now, Jupiter, I can guess this right, is about where you are, Matt. So can you just put your hand up and touch the string? Yep, it's about there. That is Jupiter. Moving on, this guy, can I get your attention? Can you just put your hand up and touch the string? There is Saturn. Don't hold on to the string. Ruin the whole solar system. Moving along, Uranus, if I've got my sums right, it's about where you are, sir. So can you just put your hand up? That's where Uranus is. And Neptune is with our friend over on your right. So that gives you an idea of the distances of things in the solar system. So remember, if you can do this, I'm going to be very proud, because I can't. Remember where you are on all of this. You're that little ant looking up at the Canary Wharf Tower as the giant hand reaches from the skies and picks it up and carries it off to his house, which is Everest, which is this small pile of salt here up the front, attached to this Earth, of which we could fit 40 across that string, and then that's the size of the solar system. So, if you're not feeling small yet, then you haven't been paying attention. Now, let's get the rest of these stars here. Just quickly. It really is that colour. I had to look that up. I was quite shocked. I didn't know they came in white, but they do. So let's get a few more stars. That is Sirius. That is the brightest star in the night sky. And yes, it really is that colour. Coming up next is Pollux. They've actually found a planet orbiting around Pollux, basically. Arcturus is the next one, I believe. I've been right. That's missing a 0. There should be an extra 0 on that one. Rigel is one of the, that's the next one, it's one of the legs in the constellation Orion, if you're wondering. This next one is awesome. That's why they call it a red giant. It's, I think it's pronounced Beetle. That's Antares. Cephei is coming up. And finally, That is, it's actually VV Cephei, it's not a W. That is one of the biggest stars we've ever discovered. It is, as it says here, that's about 300,000 times the size of Earth. On our model, if that thing wandered into the solar system, it would come basically at just about, where am I? Yeah, just about where Uranus was. So if this, can you put your hand up again, sir? Out. So that's, if it wandered into our solar system, we're in big trouble. Now, as sort of solid objects go, they're not really solid, but they're at least, there's an object there. That's more or less the biggest single thing in the universe. Even if you turn up next week, there's a talk on black holes, which I can recommend. Even the biggest black holes in the universe, a billion times the mass of the Sun, are still only about that size, the size of this planet, this star. So, in terms of solid lumps of matter, that's about as big as it gets. The next real grouping that the solar system is in is the galaxy. And it's at this point that things get a little bit desperate. Because it's big. So, what you're going to need... Oh, where are we? That's Google Earth again. What you're going to need for this exercise is a single human hair. There we go. The other thing you're going to need is a pencil. Sharp. So if you zoom in on a human hair, it looks like this. It's less than 1/10 of a millimeter across, and it's... What you're going to do with your pencil is you are going to draw the orbit of Neptune on your hair. Like that. That is the end of the piece of human hair. I'm not going to attempt it. If you do that, you might blow out a few other orbits as well. Yes? This whole thing here, in fact twice this. Remember, this is just the Sun to Neptune. Is that bothered? Sorry, I didn't actually plan for this now. I'm not sure what the string should do at this point. Is it bothering anyone? Do you need to put it down? Are you strong? Is everyone able to? Good. Okay. So that whole distance there, in fact, twice that. Remember, that's just the Sun to Neptune. The whole thing orbits. Possibly the other way. I'll work that out later. So we actually need twice that. So we're out into the foyer on your single human hair. Now, if you have a human hair, if you have a hair at this point, it'd probably be a good idea to have a look at it, because it really is a truly phenomenally small thing. On this scale, how big is the galaxy? That's Cambridge. That's the Milky Way, an artist's impression. If you can imagine that, you're doing very, very well. It's 10 kilometers across for those playing along at home. With the solar system on one of your hairs, the galaxy is 10 kilometers across. Take your time with that one.